Hello, Year 7. Right, so today's lesson is all about why some things will float and some things will sink. So you've got some examples there. You've got two different sizes of bowling ball. One's floating a little bit on the surface, one's sunk to the bottom, and then you've got some cans of pop. Okay, so this is the regular one. This is the regular Mountain Dew, and this is a diet Mountain Dew. Okay, so you can see it's floating, but the top of it is just at the surface, and we need to think about why that's the case. Okay, so it's to do with the forces that are applying on them. So it's if you try and push an inflatable toy into a swimming pool and try and push it underwater, it's really, really difficult, and that's because the water is actually pushing up against that inflatable. So if it's a rubber ring or flamingo or something, the water is pushing upwards against that inflatable. So it's trying to prevent you from pushing the inflatable into the water. Okay, and that upward force is called upthrust. Okay, so the upward force of the water is called upthrust. Now, when things float, just bear with me, you've got a floating rubber duck. Okay, so remember, forces act in pairs, and because it's floating, okay, there is the force of gravity that is pulling down on the duck, okay, but the water is pushing up. So there's upthrust against the bottom of the duck. Now, if you look at the arrows, because they are both the same size, then the duck will float on the water because the force of gravity pulling it down is balanced by the force of upthrust pushing it up. Okay, in the same way, if you've got a boat, okay, in the same way, you've got the weight of the boat because gravity is pulling it downwards, and then you've got the upthrust of the water. Now, because those two forces are equal, if you look at the arrows, they're the same size, and then the boat will float. Okay, now what we need to think about is why that is the case. So you've got a little exercise to do here. So you've got 4 shapes, okay? I want you to just write down on a piece of paper what you think each of these shapes is going to do. Is it going to float or sink? So you need to look at the size of the arrows and the direction of the pairs of arrows, okay? So pause the video, do the work, and I'll go through the answers. Okay, so the circle, the arrows, the upthrust pushing upwards and the gravity pulling down, is the same. So they are balanced forces, so the circle will float. Okay, the rectangle, the purple one, gravity is a smaller arrow than the upthrust. Now, the water can't push the block up off the surface of the water. So where this one might float, where the circle one might float sort of like the bowling ball did in the first picture. So if I go back to this one, like the orange bowling ball, that would be like the circle. So it's floating about halfway. Okay. Now, if you look at the rectangle one again, because the size of the upthrust is so much bigger, that block will float on the surface of the water. So it'll actually float on the surface. Okay. Now, the green triangle, you've got upthrust going upwards and gravity pulling downwards. Because the gravity arrow is bigger, gravity is a bigger force, it's unbalanced, and that triangle will sink. Okay. So because the gravity force, the weight force is bigger, then that green triangle will sink. Right, the red circle, okay, again, you've got the two forces, so it will be very similar to the pink circle, and because the forces are balanced, then it will float, and it will float sort of halfway on the surface, okay, so the purple rectangle will be right on the top of the surface, the red and the pink circles will be sort of hovering like the bowling ball was in the first photograph, okay. So sometimes things that are the same size have got a different mass. So mass is to do with how heavy things are. So you've got a bowling ball and a football. I know I would much rather have a football dropped on my toe than a bowling ball. They're the same size, but the bowling ball is much heavier, okay? And we need to be able to think about how the weight of something affects whether or not it will float or sink. Okay, so you've got another little activity there, which I'll come back to in a second. Now, it's to do with density as to whether something will float or sink. So it's how much mass is contained within a certain space. So the more tightly packed things are, then the more dense it is, and the heavier it will be because there's more mass packed into a small space. So you've got the first square there with 3 circles in. they're quite spread out. That's not very dense. And as you get more and more packed, the square is the same size, but as you get more circles packed into that square, then it becomes more dense. Okay, and you've got an equation there that the density of an object is the mass divided by its volume. Okay, so the volume is how much space it takes up. The mass is the weight in it's the mass in grams or kilograms, and the volume is how much space it takes up. So you've got an example there. If you've got some wood that's 20 grams and it has a volume of 10 grams, using my equation, if I do 20 grams divided by 10 centimetres cubed, then my density will be 2 grams per centimetre cubed. Now the reason that we do this is so that we can compare different materials. Okay, and you're going to have a practice at working out these densities for some values in a second. Now the first thing that you need to do is calculate the volume of your object. Okay, so you've probably done calculating volume at primary school. It's the length times the width times the height. Okay, so it doesn't really matter what you call which, as long as you multiply those three numbers together. So with the one on the left hand side, you've got 2 centimetres by 5 centimetres by 8 centimetres. So I'm going to times 2 by 5 and then by 8, and that will give me my volume. So 2 times 5 is 10 times 8 is 80 centimetres cubed. Okay, this one here, the white one, I've got 3 centimetres by 4 by 7, so I'm going to times 3 by 4 and by 7. Okay, my maths isn't that good. The last one, the orange one in the corner, is going to be 8 centimetres by 4 centimetres by 2 centimetres. So it's going to be 8 multiplied by 4 multiplied by 2. Okay, so that gives you the volume that these cuboids take up. Now you're going to practice this on one of the sheets that's on class charts. This one, in fact. Okay, and I'll go through the answers on Monday. Now, to work out the density, once we know the volume, if we know the mass, then we can work out the density, okay? And that's the second part of the task. So you're going to calculate the volumes of these cubes, and then what you're going to do is you're going to practice using some calculating some densities, okay? So you'll probably have to add another column to this table. So for material A, you've got a mass of 40 grams and a volume of 10 centimetres cubed. So you're going to do 40 divided by 10, which will give me 4 grams per centimetres cubed. Okay, and then you're just going to do exactly the same for each of those materials. So you'll draw an extra column on the right hand side and you'll write down the density. So remember, density is mass divided by volume. Okay, now this question 2 and 3, you have to be really, really careful because the units are different. Okay, so we've looked at grams and we've looked at centimetres cubed in the table. In question 2, you've got metres cubed and a mass of 48 grams. Okay, so we can't do that straight away because they're different units. So what I suggest is that you convert 48 grams into kilograms, which will be divided by 1,000, and then you can use that mass divided by 6 metres cubed. Okay, now for number 3, what you're going to do is, because you've got your volume of 50 centimetres cubed, it's easier to convert the mass units than it is the volume units. So this time what you're going to do is you're going to convert the kilograms into grams. Okay, so 100 kilograms, convert that into grams, and it gives you a little clue underneath by saying you multiply it by 1,000. So you'll get a mass in grams and then you'll divide it by your volume in centimetres cubed. Okay, so those are the 2 tasks that you're going to do. Okay, they are on class charts as well, or you can just write them on paper from the video, and I'll share the answers with you on Monday.